roots, which meant that all of your answers had whole numbers, right? Even if it was in a fraction form, everything simplified down to a whole number. Today, you will see a difference. So first of all, irrational numbers are things that are not, if it were a decimal, it's not a terminating or a repeating decimal. So for example, pi is an irrational number because the decimals don't have a pattern and they don't repeat and they also go to infinity, they never end. So an example of that. In terms of a square root, let me give you just a quick example and then we'll get into the problem samples. Yesterday we did things like, let's say, the square root of 4. And you guys could tell me that the answer to the square root of 4 was 2. I don't know if you guys remember back to 6th grade, in A Wrinkle in Time, when Meg was trying to resist getting pulled into the man with red eyes, and it was trying to take over her brain. Her dad yelled out, this was when they were back in Camazotz, and her dad says, Meg, what's the square root of 5? And she knew. The answer, which I don't even know, I gotta type it here. Whoops, square root. 2.2360667, what? And this decimal, this is just what my calculator can show. It might continue to go. So an example of an irrational square root is one that is not a perfect square. Square root of 5, square root of 10. A number that does not just have a whole number answer. So what you're gonna see today is that if you have a number like the square root of 5, where there isn't a whole number answer, you're going to leave it in this form. You're not going to say 2.2360679. We're going to not use the decimal part. For irrational square roots, you may have some parts that you can't simplify any further into a whole number. And what we're going to be doing is starting with the strategy we used yesterday of taking a bigger number and breaking it down into parts, factors that multiply. And the first thing we want to try to do is to try to find, again, factors that are perfect squares. Now this one, I'll tell you right now, this one will simplify down to a whole number answer. So you might see some of those. This one is actually going to be a rational square root, so it's a little bit of review from yesterday. Again, I like to always start by adding up the digits. 3 plus 2 is 5 plus 4 is 9. Oh, 9 divides by 9, which means this number divides by 9. And again, you can use your calculator to go, okay, 324 divided by 9, oh, that gives 36, another perfect square. So again, this example is going to have just rational square roots. Remember that we take the square root of each part separately. The square root of 9 is 3. The square root of 36 is 6. And because it's always multiplying, we multiply those two whole numbers to get our final answer. So that's just like yesterday's. Again, it's going to ask you to simplify, and so that's going to mean not just punching it into your calculator and getting a decimal, but working in this method. So let's start with a relatively small number, the square root of 75. Can anybody think of our list of perfect squares, of a perfect square that would be a factor of 75? CJ? 25. Very good. 25 times 3 makes 75, so I'm still using 75 here. Now, we can break this into separate pieces. If it helps you to think about it broken apart, square root of 25 times the square root of 3. You don't have to rewrite that step if you can keep straight the difference between what's going to become a whole number and what's still going to be a square root. The square root of 25 is 5. But the square root of 3, I don't know what that is. I could check it on my calculator, but it's going to be some kind of decimal. And we're not going to use the decimal. We're going to leave it as the square root of 3. We can push them together because it's being multiplied. So that's how I will show the answers. You can keep the dot in the middle if you like. But 5 times the square root of 3 is the answer. Because 3 doesn't have any factors. We can't break that down and get any perfect square factors out of that. Let's do another one. Make it a little bit bigger of a number. Now this one also has a whole number outside and then a square root. So 2 times, again we're just pushing it next to it, which means times, 2 times the square root of 112. So we need to take that 112 and start breaking it apart into its factors. Again, looking for a perfect square. Anybody have an idea of a perfect square number that would be a factor of 112, either just using mental math or your calculator? Luke?
4.
Okay, good. Again, to use the divisibility rule for 4, we look at the last two numbers and just read them as a number, 12. 12 divides by 4, so this will divide by 4. Now, 112 divided by 4 leaves 28. Now, the first thing we can do here, this is going to take us a couple steps. If we want to stop here and go ahead and take this part out from under, oh, by the way, I don't think I said this yesterday, just so you guys know, this sign is called the radical sign. It's totally radical, dudes. I don't know why it's called the radical, but it is called the radical. It's not totally rad, but, you know. So if we want to take this out from under the radical sign, because I know I can do the square root of 4, the square root of 4 is 2. Well, I had the 2 that was already out front. The square root of 4 is 2, so I have that 2. But now I still have 28. Is there anything else I can do to the 28 in terms of factoring it using a perfect square? Leanna?
4.
Yeah, 4 times 7 is 28. So we can keep going with this. You can't just stop here. If this was, let's say, 26, there's no perfect square number that's a factor of 26, then you could leave it. But as a 28, we could do 4 times 7. And again, this piece, the square root of 4, I know that piece. I had the first 2, I had the second 2 from that first square root of 4. Now I have this square root of 4 equals 2. And then I'm left with the square root of 7. And the 7 has to stay under the radical. It's a prime number. There's no other factors, and it's not a perfect square. So now I just multiply 2 times 2 times 2, 8, times the square root of 7. So one of the things you have to keep straight is which numbers are still under the radical sign and which numbers are not, because we have been able to take the square root. Square root of 4 is just plain old 2, no radical, just a 2. Square root of 7, still a square root, stays under the radical sign. Okay, any questions on that one? Then we just have, I think, one more. No questions there, okay? What else? What was my other one? The square root of 891. Again, we want to just look for, oh, I think I do have one more after this, sorry, I lied. 1 or 2. Again, trying to break this down into factors that are perfect squares. We could try adding up the digits. 8 plus 9 is 17, plus 1 is 18. 18 divides by 9, so this will divide by 9. Now, there might be a bigger factor. If you want to try other ones, I'll tell you right now that this also divides by 81. I wouldn't expect you to know that. There's no divisibility rule for divides by 81. But you could try other numbers, but we'll get to the same answer either way by just doing divide by 9. So 891 divided by 9, I get 99. So 9 times 99 gives me my 891. If I take the first piece out of the radical, the square root of 9 is just plain old 3. And now I still have the square root of 99. Any perfect squares that are factors of 99? Carissa?
9.
Yeah, how about 9 times 11? And then again, I have another square root of 9, which is another whole number 3. So 3 times 3 times the square root of 11. There's nothing I can do with the square root of 11, so 3 times 3 is 9 times the square root of 11. There's my answer. Now just to show you, if you had tried some of the other numbers, I think I mentioned 81 is a factor of this. If you do 891 divided by 81, because you tried that number, 81 times 11 makes 891. Square root of 81 is 9 times the square root of 11. We're just done a little faster. But I wouldn't expect you to know that 81 works there. You can try any number you like. Okay, last 2 examples, real quickly. This won't take long. You are going to get a couple questions. I'm going to ask you to do a couple where you are going to use your calculator, and it will say approximate the square root, I think it says to the nearest 10th or 100th. There's a couple different ones. So I'll do to the nearest 100th, just as a practice, but check your homework. Some of them say to the nearest 10th, and some say to the nearest 100th. Okay, so, for example, the square root of 684. So here all you do is you get to use your calculator. You say 684, you hit the square root button, or now mine goes a little backward. I have to hit the square root button second, but I showed you guys if you need help with your own calculators today, just let me know. I'll come around and show you how to use it. 26.153393 to the nearest hundredth. What digit is in my hundredths place? Diego? The 5. I look over to the 3, which says round down, and round down actually means just keep it the same. So 26.5, I'm sorry, 0.15 would be my final answer. So don't forget how to round. If you need a reminder on that, again, raise your hand. Check though, it might say to the nearest 10th. If it was to the nearest 10th, we'd round to where the 1 is. If you look over, we see a 5, that means round up, so 26.2. So if you have anything that says approximate to the nearest hundredth, you're just using your calculator. This, as you can see, is not a rational square root. If it was rational, we'd get a whole number. And then we don't, we get a decimal. And that's it. That's all I need to show you.